Two particles A and B having charges 8 into 10 to the power minus 6 and minus 2 into 10 to the power minus 6 respectively are held fixed with a separation of 20 centimeter. Okay, where should a third charged particle be placed so that it does not experience any electric force? Okay, so let me draw a rough diagram. So here we will put our first charge at any point A, let's say. Okay, and this is another one at B. Okay, and the separation between A and B is how much given here? 20 centimeter. Okay, we have to place the third charge. Let's place it here somewhere at C. Okay, at a distance of x centimeter from B. Clear it is? So separation between A and B is 20 centimeter and separation between B and C is x centimeter. Clear? All of them are in centimeters. Okay, now at A we have the first charge, which is how much? 8 into 10 to the power minus 6 coulomb. Okay, and at B we have second charge, which is minus 2 into 10 to the power minus 6 coulomb. Clear? Now they are saying where should we place the third charge? Okay, the charge which is to be placed at point C, so that the net force is 0. Clear? Now first thing, to get the net force to be 0, okay, the resultant at force at C, okay, will be 0. Clear it is? So here let's figure out our force due to A on C. So force on due to A on C will be force on C due to A will be equals to K, which is 9 into 10 to the power 9, okay, into the first charge, which is 8 into 10 to the power minus 6, okay, and let's assume the charge which is to be placed at C is Q. So capital Q, I am placing here capital Q, okay, whole divided by, what's the gap between A and C? The gap will be 20 plus x into 10 to the power minus 2, correct? Equation number 1. So we placed our charge at C, which is at a distance of x. Now let's figure out the force on C due to B. That will be equal to 9 into 10 to the power 9 into, what is our charge at B? 2 into 10 to the power minus 6. Be very careful, you will not take the negative sign, okay, into consideration here while calculating the force, into any charge Q, okay, which is to be placed at C, whole divided by separation x into x square, or you can make it here as x into 10 to the power minus 2 whole square. Okay, so we have not made here whole square, so let me put here whole square, because the formula for force is k q1 q2 by r square. This is our equation 2. Okay, now as per the question, the resultant force must be 0, and if the resultant force is 0, this force on C due to A must be equal to force on C due to B. So let's equate both the equations. So from 1 and 2 we can write 9 into 10 to the power 9 into 8 into 10 to the power minus 6 into Q whole divided by, we have 20 into 20 plus x, 20 plus x and in whole power 2, and 10 to the power minus 4 I am taking here outside. From where I got this 10 to the power minus 4? 10 to the power minus 2 whole square is 10 to the power minus 4, and let's put it equal to 9 into 10 to the power 9 into 2 into 10 to the power minus 6 into Q whole divided by x square into 10 to the power minus 4, correct? Now let's cancel out the common terms. So 9 into 10 to the power 9 cancels out both the sides, 10 to the power minus 6 cancels out both the sides, Q cancels out both the sides, and 10 to the power minus 4 cancels out both the sides. What we left with here is 8 upon 20 plus x whole square, correct, is equals to 2 upon x square. Let's cross multiply here. So this will be 8 upon 2 must be equal to 20 plus x whole square upon x square. I hope this is clear. So 8 by 2 is 4. So 4 is equals to 20 plus x upon x. We have combined both of them whole square, and taking square on the left hand side it will be 2, which is equals to root, because square if you take it on the left hand side it will become root. So root of 4 is 2 equals to 20 plus x whole divided by x. Let's now cross multiply. So this will be 2x is equals to 20 plus x, and taking x on the left hand side it will become 2x minus x is equals to 20. and 2x minus x is how much? It is x. So x is equals to 20 centimeter. So our correct answer here is 20 centimeter.